Okay, I'm going to review some homework questions from the pre-calculus section 5.2. The assignment is 1 to 41 odds. Some of the questions asked were 11, 12, 21, 29, 31, 37, 41, 45, and 50. So we're going to go through some of these. Excuse me. To do these, you really have to know your identities. Cosine of A minus B factors in, or it doesn't factor, but what does it become? It becomes cosine, cosine, the opposite, so it's plus, then sine times sine. So what we're going to do is we're going to fill in to what A is and what B is. So what's A? Is A x? What's B? Pi over 4. Now, do we know what the cosine of pi over 4 is? Do I know what the sine of pi over 4 is? If you factored out the radical 2 over 2, you would be left with cosine plus sine. Now, that should match what we're trying to make it match. Okay. I was told 12. You're okay with 12? So you don't need 12. 21 is a tangent, so you need to know a tangent formula. The tangent formula of the tangent of A plus B. This is going to become tangent A. I believe the opposite, no, the same sign, so it'd be plus tangent of B all over 1 minus tangent A times tangent B. Let me just verify. Looks right to me. So I'm going to have tangent plus tangent over 1 minus tangent times tangent. Now all I have to do is fill in A and B. What is A?
Pi over 6.
So wherever I see the A, I put a pi over 6. What's B? So where I see the B, I put the pi over 4. Now, the tangent of pi over 6 is going to be on your trig table, or maybe you know it. I believe it is radical 3 over 3. How about tangent of pi over 4? It's just a 1. All divided by 1 minus tangent of pi over 6, we already knew from up top, which is radical 3 over 3, you're right, times tangent of pi over 4, which is 1. So what does this become? Radical 3 over 3 plus 1 divided by 1 minus radical 3 over 3. I will never accept a fraction within a fraction, so we need to resolve this somehow. So what I'm going to do is I'm going to multiply by what's being divided by. The opposite of dividing by 3 is to multiply by 3. So I'm going to multiply by a fancy form of 1, namely 3 over 3. If I multiply by 1, I don't change its value. When I multiply here, the 3's will cancel, the times 3 and divided by 3, leaving me just the square root of 3. 3 times 1 is 3. 3 times 1 is 3. But when I multiply here, these 3's would cancel, leaving me radical 3. So at this point, I have radical 3 plus 3 divided by 3 minus radical 3. To my knowledge, you're not allowed to leave radicals in the denominator. So I need to get rid of that square root in the denominator. I'm going to do that by multiplying by the conjugate of the bottom. The conjugate of A minus B is A plus B. When you multiply those, you get A squared minus B squared. So the conjugate, instead of 3 minus the radical, is going to be 3 plus the radical. 3 plus the radical. On top, you get the quantity squared, which you can either just write as 3 plus, let me go back to yellow for this one. You can write just on top, what would I have? 3 plus radical 3 quantity squared. If you want to square it out, we can. But on bottom, you get a squared minus b squared. So if this is a, if this is a, what's a squared? 9 minus, because of the formula, this is b, what's b squared? Square root of 3 squared is 3, isn't it? So what do you get here? I don't know if you want to square this or not. Square the first, twice the product, square the last. So what does that become now? It'd be over 6, but let's clean the top up first. I'll put it over 6. 3 plus 9 is 12 plus 6 radical 3. They're both divided by 6. So I think you'd have 2 plus radical 3. Let me check the answer. I'll be right back. From looking at the book's answer, unfortunately, they don't require you to do any of this. They have an answer like this where they leave a radical in the denominator. So I guess if the book is happy, I'll be happy if you can get to that point. Okay, so after 21, I believe the book's answer was wrong. I think this is correct. 29, we need to know which formula involves sine A cosine B with a minus cosine A sine B. Now, do you know which form that is? Because if it's a cosine, guys, if it's cosine, it goes cosine, cosine. Does this go cosine, cosine? No. So I know it's going to be a sine. I know that sine of A minus B, because with the sines you use the same sign. So this is going to equal the sine of A minus B, because that's what this identity is. I'll write it out if you like. What are our identities? Let me write them out. We know that sine of A, let's start with cosine. I always like to start with cosines. Cosine of A plus B is cosine A, cosine B. Opposite sign, sine A, sine B. Does it match that one? No. Cosines go cosine, cosine. Then the opposite sign, sine, sine. Does it match this one? No. Sine of A plus B is sine A cosine B, same sign, sine B, or actually reverse it, they do cosine A times sine of B. Does this match it? No? Okay, it has a minus, right? So we'll get to our last one. Sine of A minus B is sine A cosine B, same sign, cosine A sine B. Does it match this one? I think it's this one, isn't it? That's why I wrote this. So, what do we have? We have the sine of, what's A? 5 pi over 12. What's B? What do you need to add or subtract fractions? Common denominator, which would be 12. This is 3/12 the same as 1/4? Yes. So what is this? 5/12 minus 3/12 is 2/12, which simplifies to what? 1/6, and the sine of pi over 6 is 1/2. Okay, after 29, somebody asked me this one. Because it has a minus on top, I know that tangent A minus tangent B all over 1 plus tangent A times tangent B. I know that this is going to equal tangent of A minus B. The way I can tell the tangents are, it has the same sign on top. So I noticed that this had a minus, so this would have a minus. So anyway, this is going to be tangent of A minus B. What's A? Minus, what's B? What's a common denominator? 30. So I'd have tangent of, would that be 6/30? Minus 1/30 leaves you what? 5/30, which is what? 1/6. And the tangent of pi over 6, I think we know pretty well if we paid attention earlier, is radical 3 over 3. And after 31, we may try 37. So we want to verify this. So I know that, let me do it in a different color. Tangent of A minus B, I know that that's going to become tangent of A minus tangent of B all over 1 plus tangent of A times tangent of B. So pretty much I just need to fill these in. So let me just, give me a second and we'll fill in what A and B are. So what is A? 2 pi. What is B? X. Now, what is, do you know on the unit circle where 2 pi is? 2 pi is over here at 0, right? What are the coordinates? 0? No, it's not. What are the coordinates? It would be 1, 0. Cosine, sine. And if I need the tangent, it's sine over cosine, right? So what's the sine? 0 over 1. So I believe the tangent of 2 pi is going to be 0. So this tangent of 2 pi is 0 minus the tangent of x. On bottom, tangent of 2 pi is 0 times the tangent of x. So that gives me negative tangent of x over 1, which is negative tangent of x, which is what we're trying to demonstrate. Okay, after 37, somebody asked me 41. So what I need to do is probably break up something on top. I have this on top, the sine A minus sine B. Is there a rule for sine A, minus B? I believe it's sine A cosine B. Same sign, you're right. And this would be what? Cosine A sine B. Okay. And what is that divided by here? So this is divided by cosine A cosine B divided by cosine A cosine B. Does anything divide out? What divides out here? Cosine B's. And over here, what divides out? Cosine of A's. Does that look right? So what's that leave me with? Sine A over cosine A, which is called tangent of A. This is sine of B over cosine B, which is the tangent of B. And now it matches. Okay, after 41, I was asked 45. Well, probably looks like we have a couple of them to do here. So, cosine is cosine alpha, cosine beta, opposite sign, sine alpha, sine beta. Now you're taking that times this other one, which is going to be cosine, opposite, so it's plus sine, I want to use alphas, sine alpha, sine beta. Now when I multiply this out, what happens? When I multiply here, would it be that quantity squared? Yes. Cosine alpha, cosine beta, and that would be squared. When I multiply here, what do I get? I think I get, there's a plus, so I'll put a plus. I get cosine alpha cosine beta times what? Sine alpha sine beta. Now I'm going to distribute this negative thing here. What does this give me? Would this give me negative cosine alpha cosine beta times sine alpha sine beta? And when I multiply here, I get a minus, don't I? Yeah. And what would I get here? It would be that quantity squared, wouldn't it? Yeah. Sine, but that quantity is squared. So, what happens here now? Let's put these together. What do we have here? These would add to 0 in the middle, wouldn't they? Okay, so I have cosine alpha cosine beta squared. How could I write that now? Cosine squared, because it's multiplied, minus what? Sine squared, sine squared. Let's see if we can't factor anything out. Give me one moment. Okay, I can't really seem to get it to match this currently. I will come back, ask me next period. I'll see if I can look at it with a fresh set of eyes. But let's see if we can do 50 here. Do we know a rule for sine A plus B? It would be what? For sine would be sine x, and then cosine of the b, cosine of h. It'd be the same sign, right? So it'd be a plus. And now it would be the other way around. Cosine of a, which is cosine x, times the sine of b, which b is h, right? And this is minus the sine of x, and the whole thing is divided by h. Just looking at what they did, they rearranged it. They take sine x cosine h, then they put the minus sine x here, plus cosine x sine h. Is that still the same thing that I have in the numerator, just in a different order? And they have this over h, and they have this over h. Still the same thing. Can I factor a sine out of the top? If you take a sine out of the top, what would remain? Cosine h minus 1 all over h, I think. And over here I have cosine x over h times sine of h. Now let's see how we can make this match somehow. Yeah, we rearranged it a little bit. I put the sine in front here, put this at the end, and then I took a sine x out of these. So I took the sine, I factored the sine x out, giving me this. And then I kind of just separated it. This is over 1, top times top, bottom times bottom. And I don't know if you can see because it's in a slightly different order, but that does match this.